Hey folks, welcome to my channel number 10. So in this video, we are going to look at integral of cosecant x dx, right? Again, an integral which I would recommend you folks to remember it because it could come in handy when you solve complex problems in integral calculus, right? And even if you're not able to remember it, it is still fine, but I want to ensure that you folks are familiarizing yourself with our approach to solving integral of cosecant x dx, and I request you to take a look at my other video where I've solved for integral of secant x dx as well, which is on very similar lines, right? So I know that my cosecant x equals 1 by sine x, but is that really going to help here? The answer is no. So let me rewrite my y. My cosecant x is nothing but cosecant x into 1, right? And therefore my y is nothing but integral of 1 into cosecant x dx, or cosecant x into 1 times dx, right? And this is where, like we saw in our secant x video as well, my 1 can be written or re-expressed in a zillion ways, right? And we're going to use one of those zillion ways to simplify y and solve it by the method of substitution, right? I know that my 1 can be rewritten as secant x plus cot x whole divided by cosecant x plus cot x, right? Now I go back to my y, right? And then I rewrite the 1 inside my y as cosecant x plus cot x the whole divided by cosecant x plus cot x, right? So let's see what do we get. So this is what I get. Now I keep the denominator as it is, and I'm going to multiply the cosecant x with the cosecant x plus cot x and re-express my numerator, right? So my cosecant x into cosecant x in the numerator becomes a cosecant square x, right? And my cosecant x into cot x becomes cosecant x cot x, right? And my denominator is cosecant x plus cot x. So that's my y. Now, am I in a position to simplify my y? See, I have a cosecant x plus cot x in the denominator. I have a cosecant square x plus cosecant x cot x in the numerator. And I want you to recollect some of the formulas what we have done earlier in differential calculus. I know that my d by dx of cot x is minus cosecant square x, and my d by dx of cosecant x is minus cosecant x cot x, right? So what's that substitution that's going to simplify y for us? I'm going to do t equals cosecant x plus cot x, right? Therefore, when I differentiate on either side, I get dt by dx equals minus of cosecant square x plus cosecant x cot x, right? Now you see, I get the negative of what I have in my numerator above, right? So this is my dt. So now you see what I have is as dt is nothing but negative of what I have in the numerator inside my y, right? So I go back to my y. So my y becomes integral of, I see that my cosecant square x plus cosecant x cot x dx is what I have in the numerator, which is nothing but a minus dt, right? And I want you to connect this with what we have done just now. So I'm just highlighting that in yellow. So my numerator becomes a minus dt. I'm going to pull out the minus sign. And then my denominator, which is cosecant x plus cot x, becomes a t, right? Now, this is something very familiar to us, which is minus ln of mod of t plus c. And I pull my minus sign inside the ln, and I will land up with 1 by mod t, right? Plus c, right? I cannot leave my answer in terms of t. I'll have to put back everything in terms of x, right? Now I have my answer as ln of, I know that my mod of 1 is nothing but a 1. I can pull the 1 out of the mod. But then before that, you see that we have a cosecant x plus cot x, right? So is there a better way to represent my final answer is what I want you folks to think through, because my answer looks like it is a ln of 1 by mod of cosecant x plus cot x, right? So what would happen if I do a simple multiply and divide by a cosecant x minus cot x, right? If I do a simple multiply and divide by a cosecant x minus cot x, I will end up with ln of, I want folks to follow me carefully here. My numerator becomes cosecant x minus cot x, right? And then my 1 remains as it is, I don't disturb it, but my denominator becomes a, a mod of cosecant x plus cot x into cosecant x minus cot x, which is nothing but a cosecant square x minus a cot square x, which we know from our trigonometric identities that it is nothing but equal to a 1, right? So when I multiply and divide by a cosecant x minus cot x, right, what do I get? My denominator becomes 1 and my numerator becomes a cosecant x minus cot x. So I get a mod of cosecant x minus cot x inside my ln expression, right? My answer to this problem is ln of mod of cosecant x minus cot x plus c, right? Again, drawing your attention to three important trigonometric identities. Secant square x minus tan square x equals 1. Cosecant square x minus cot square x equals 1. And sine square x plus cos square x equal to 1, right? So there we are. So let me highlight my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.